Good day, dear listeners. Believe you all are doing well. Today we are going to discuss the periodic table. Periodic table is a table that arranges elements in a systematic order. First of all, I believe we are all conversant with the concept of elements, but in a brief way, I have to discuss or I have to define what an element is. An element is a substance which cannot be split into a simpler form by ordinary chemical reaction. In the periodic table, the elements are grouped into 8 different groups. They also have 7 periods in the periodic table. The group 1 elements are called the alkaline metal, the group 2 alkaline earth metal. Then we have the boron family, which is group 3. We have the carbon family, group 4. We have the nitrogen family, group 5. We have the oxygen family, group 6. We have the halogens, that is group 7. And finally, we have the noble gases, the rare gases, or the inert gases. They are the group 8 or group 18 elements. Then, there are also a set of elements that lies between group 2 and group 3 of the periodic table, which are called the D block elements. We can clearly distinguish between a D block element and transition metals. D block elements are those elements whose electronic arrangements terminate with the filling of the D block orbitals. I take that again. The D block elements are those elements whose electronic arrangements end or terminate with the filling of the D orbital. Then transition metal, on the other hand, are those elements that have partially filled D orbitals. So the D orbitals or the D block elements have 3 different series. We have the 4D series, we have the 3D series, and we have the 5D series. Then below the D block element, we have also another set of elements called the F block element. They include the lanthanide and the arsenide series. So altogether in the periodic table, we have the S block element, which are basically group 1 and group 2, that is the alkaline metal and the alkaline earth metal. Then we have the P block element, which start from group 3 of the periodic table to group 8 of the periodic table. Then we have the D block element, and finally we'll have the F block element. Don't forget that we have what is called the periodicity of an element. These are the changes in the properties of the element as we go down the group and across the period. So periodicity is the continuous variation in the properties of the element both down the group and across the period. The elements in the periodic table are arranged based on their atomic number. So what are those properties that varies both down the group and across the period? They include electronegativity, electron affinity, ionization energy, electropositivity, ionic radii stroke atomic radii. We have melting point and boiling point. These are those periodic trends that varies both down the group and across the period. Also, elements in the periodic table can be grouped as either metals, non-metals, or metalloid. Note, there is no clear-cut distinction between metals and non-metals. Notwithstanding, on the basis of ionization, we can categorically differentiate between metals and non-metals. So metals are those elements that ionize by loss of electron. Examples include calcium, sodium, potassium, silver, copper, zinc, iron, cobalt, nickel, etc. Those elements that ionize by loss of electron is what is called metals. Then, contrary to that, non-metals are those elements that ionize by gain of electron. They include chlorine, bromine, iodine, hydrogen, nitrogen, oxygen, sulfur, phosphorus, argon, etc. These are the non-metals. Then we have the ones that are at the borderline between the metals and non-metals. They are the ones called metalloids. Some authors call these semi-metals. So the metalloid are those elements that are at the borderline between metals and non-metals, which means they exhibit this dual property. What are those properties that are particular or peculiar to metals? We have the physical properties of the metals, such as the thermal and electrical conductivity. That is to say that metals are good conductors of heat and electricity. Aside that, metals have high melting point and boiling point. They are hard but not brittle. Metals are sonorous. Metals are malleable. Metals are ductile, etc. These are some of the physical properties of metals. Then when you talk about the chemical properties of metals, you talk about the reaction with oxygen. Metals react with oxygen to form a basic oxide. This basic oxide, on exposure to the atmosphere, absorbs moisture and turns into alkali. An alkali is a basic hydroxide that is soluble in water. Metals such as zinc react with acid, that is reaction with acid. Metal reacts with acid to liberate hydrogen gas. Every metal that is higher than hydrogen in the activity series displaces hydrogen from its acid, just like I've mentioned earlier. When zinc reacts with dilute mineral acid, there's a liberation of hydrogen gas from such acid. There are some other unique properties of the metal, but for the sake of this video, let's look at the major differences between the metals and non-metals. As metals are good conductors of heat and electricity, non-metals are poor conductors of heat and electricity, except graphite, which is an allotropic form of carbon. It's a good conductor of heat and electricity. Then aside that, metals are malleable, non-metals are not. Metals are ductile, non-metals are not. Metals have high melting point and boiling point, but non-metals have low melting point and boiling point. etc. We can differentiate between the D block element, the metals in the D block element, and those of them in the S block element. There are those characteristics that are peculiar to the transition metals. One, they have variable oxidation state, they have colored ion, they form metallic complexes, they are paramagnetic in nature, and they are catalytic in nature. These are those properties that are distinguishable between the S block element and the D block element. In addition to that, the bond formed by the metals of the D block are stronger than that formed by the metals of the S block element. Reason: because in the D block element, in addition to the S block orbital, in addition to the S orbitals, the D orbital is also available for bonding. So both the electrons in the S orbital, the p orbital, for bonding, and because of this they form a stronger bond compared to the S block element.